So for our final project, we will be analyzing the MTA subway turnstile data. My name is Mandy.
My name is Masuma.
My name is Anna.
So our analysis goal is that we would like to verify which subway stations get visited the most and whether or not certain factors affect the number of riders taking the subway. By understanding what factors affect the number of MTA riders, we can figure out whether or not certain locations are underserved. The data we will be using is data from the MTA involving the number of entries and exits at various turnstiles around each subway station in New York City. We will also be using data from NYCT involving the different types of MTA fare cards purchased at different subway stations. The main attributes we used are station, which is the name of the subway station in which the turnstile is located, date, which is the month, day, and year that the turnstile data was recorded, time, which is the hour that the turnstile data was recorded, 7-day unlimited, which is the number of 7-day unlimited fare cards purchased at that station, 30-day unlimited, which is the number of 30-day fare cards purchased at that station, and full fare, which is the number of full fare cards purchased at that station. Some derived attributes that we used are entries diff, which is derived from the attribute entries given by the MTA turnstile data. Entries was the cumulative number of entries at that specific turnstile. By cleaning the data, we used entries diff to represent the incremental value of the number of entries per subway station. We also merged the MTA turnstile data with information regarding the latitude and longitude of each subway station to create new attributes called GTFS latitude and GTFS longitude. Finally, we created a new attribute subway transfers based on the attribute line name. Line name was an attribute line name was a string of all the trains available. By calculating the length of the string, subway transfers now represent the number of different trains available at that station.
Our questions are, do certain subway stations get visited more often than others? And where are these stations located? Are there more MTA riders during certain days of the week or certain days of the day? Do the number of train lines available at a subway station correlate to the number of MTA riders at that station? And how do the different types of MTA fare cards people buy at a station distributed across all of the subway stations?
So our first question is, do certain subway stations get visited more often than others? The attributes that we are going to use for this question are station, which is categorical, entries and entries difference, which are ordinal, GTFS latitude and GTFS longitude, which are geographical attributes. So looking at this graph, we can see that the top 3 most visited subway stations in March 2018 are 34th Street Penn Station, 23rd Street, and Grand Central 42nd Street. We can get a better look at this by looking at the map. So the map shows that the majority of the subway stations that are used the most are located in Lower Manhattan and downtown Brooklyn. We can also see some popularity in Queens. Our second question is, are there more MTA riders during certain days of the week, for example, school days versus weekends? And the attributes that we are going to use for this question are date, which is ordinal, temporal, and hierarchical, entries and entries diff, which are ordinal attributes. So looking at the graph, we can deduce that there are a lower number of MTA riders during the weekends, which makes sense because people are traveling the most during weekdays to go to work, school. So our third question is, are there more MTA riders during certain hours of the day? The attributes that we're going to use for this question are entries, which is ordinal, time, which is temporal, and entries difference, which is ordinal. Looking at the graph, we can see that there are 3 peak or rush hours. The first one is when people go to work or school around 9 a.m. The next one is when people go for their lunch during their breaks, which is around 11 a.m. And the last one starts around at 4 p.m. when people start going home from work. We can also notice that there is a dip early morning, which makes sense because people are not traveling during those hours, which are around 3 a.m. to 7 a.m. in the morning.
Our question number 4 is, do the number of train lines available at a subway station correlate to the number of MTA riders at that station? The attributes we are using are station, categorical, line name, categorical, entries and entries different, ordinal, and subway transfers, which is ordinal again and calculated from line name. By looking at this graph, we can see that the station with top number of riders is 34th Street Penn Station, but it only has 6 lines, whereas Times Square, 42nd Street, and 42nd Street Port Authority have less number of riders, but have 12 lines available. We can also see that the stations ranked number 2, 3, and 4 still have a lot of riders, but they have less lines, such as 3, 5, and 8. This kind of shows that there is no direct correlation between the number of MTA riders at a subway station and the number of lines available at that station. Question number 5 is, how do the different types of MTA fare cards purchased at a station distribute across subway station? The attributes we're using are station, categorical, 7-day unlimited, ordinal, 30-day unlimited, ordinal, and full fare, ordinal. By looking at this graph, we can see that the types of fare cards purchased and the number of cards purchased congregate around the 34th Street station and the 42nd Street stations. We can also see that the most bought full type of fare is the full fare, and but 30-day and 7-day unlimited are pretty high as well. So this shows that the 34th Street station appears yet again as one of the most visited stations, similar to what we had in graph 1 and 4. However, J Street Metrotech is the only station that appears from the Brooklyn borough that is in the top stations by card spot, which might mean that not as many people ride this station because it didn't appear in the top 10 for a number of riders, but it means that it has a lot of dedicated riders who always use the subway because they keep buying full fares from that station.
So in conclusion, we noticed that the subway stations that are visited most are subway stations located in Lower Manhattan. This is expected because Manhattan is where many people go to work, to shop, and to sightsee. We also saw that the number of MTA riders are affected by the day of the week and the time of the day. During weekdays, when people either have to go to work or to school, there are more people taking the subways. Peak times at subway stations also correspond to times people start their work or school day, lunchtime, and the workday ending. So looking at the graph of the number of subways available at each station and the number of MTA riders at those stations, we notice that they are not proportional. This leads us to believe that, in fact, there are subway stations that are underserved, such as 34th Street Penn Station and 23rd Street. In the graph number 4 that we saw that 23rd Street is the second most visited station, but it only has 3 different trains available. On the other hand, Atlantic Avenue Barclay is served by 9 trains, even though it's not as popular as the other stations. By discovering these correlations, our next steps is to make sure that more popular stations have more trains available, whether it be more train lines or trains coming more often at that station.